Hi everyone, welcome back. This is the 37th video in our series on building a chess engine from scratch in the Java programming language. Our focus has been on the GUI, and in this video I want to take the opportunity to use the GUI to debug some of the problems that we've encountered with the legal move engine and that have become apparent now that we have the GUI. Right, so let me see here. Let me quit my old. Let's see if we bring the game up, we can see that when we highlight the legal moves, right? Here's something goofy. We see legal moves in our diagonals that are non-attacking, right? So we know that that's not legal. You can only attack in the diagonal if an enemy square occupies that diagonal tile. And so let's see if we can fix that. Also, the pawn jumps, even though it looks like the pawn jump's correct here, it's not right, and we can see that on black. So we see this asymmetry. And let's fix the first bug. The first bug is that in here, in the pawn jump, the condition that we have is the current candidate offset is 16, and it's the first move. And, right, and we needed a parentheses around this entire condition. Otherwise, this OR is kicking in, and it's not quite right. So we really want to say this condition is true for the pawn jump. The offset's 16, and it's the piece's first move, and one of these conditions is true. Before we weren't saying that. We were saying this condition is true, and this condition is true, or one of these conditions is true. So you can step through it in debugger and verify that on your own if you want, or ask me questions about it in the comment box. But I claim now that when I run the program, we're going to see a slightly improved behavior when we highlight the legal moves. We'll see now that we don't get the pawn jump, but we also don't get these erroneous diagonal attacks. Now, in order to get the pawn jump to work correctly, we have to have the notion of the is first move correctly implemented. And if we were to command click into piece, we'd see here I've just hard coded is first move to be false. So why don't we take the time to improve on this? I don't know how far we'll get, like whether we'll be able to do all of this in one video or not and do some GUI work, but why don't we just move forward and improve the game, and we'll get to where we want. So first thing I want to do is I want to say that this constructor, right, this constructor takes the type, the alliance, and the position, and also a Boolean, final Boolean is first move, right? And we're just going to say is first move is equal to is first move. We're going to remove this to do, and we're right. So this is going to break a lot of code. When we try to run the program now, it's going to say, oh, you got all these locations where I expect this, this other parameter, and you're not giving it to me. So what we're going to do is, right? So what we're going to do is we are going to, let's look at, for example, rook, right? This first one that's broken. For each of the pieces, we're going to have a convenience constructor, right? We're going to keep the constructor. We're going to have a constructor that passes the alliance, the position, and the first move argument. And we're also going to have another one that just passes in true. So for this one, we'll say this is the convenience one. It only takes two arguments, the alliance and the position. But we'll also pass in another version that says, so public rook, because we might be creating moves elsewhere where it's not the piece's first move, right? So this is just a convenience for us that we're going to use elsewhere in our program. So we'll say alliance, piece alliance, final int piece position, and final Boolean is first move. Okay. Right? And now we're going to say super piece type rook. Let's just copy this. Really, that'll be a lot faster. And instead of passing in true, we're just going to pass in the argument. Okay, and that's it. So we're gonna go through this with each one of the pieces. So bear with me. So we did this with rook. Now let's do this with the bishop. Right. So we've gotten rid of our compiler error there. Let's look at the bishop and come up here, and we're going to pass in true, and we're just going to copy this. We're going to pass in final boolean is first move. That's going to pass in is first move. Right? So we've now fixed the bishop and the rook. Let's go to the knight. Same thing. And our board builder, I believe, currently uses this convenience constructor. So let's pass in final boolean is first move. Is first move. Now that's happy. Let's do the queen. Okay. Again, true. Oh, oops. Bear with me here. I always find it challenging to code and talk at the same time. All right, let's use this opportunity to improve this. Mark these final. Okay. So now we should only have two things broken here. Pawn. We're going to pass in true. Some of you have also mentioned that you don't see how the en passant is going to work. We're going to try to get to that shortly too. And I hope that you find it an elegant solution, but you'll see that it's sort of involves a couple things. So that looks correct. Now pawn is working. And let's do king last. Right? And king will say true. Move. Okay. So let's see. When we run this now, let's do highlight the now it shows up correctly. So we should be able to do that, and that shows up correctly. So now the pawn jumps work. Technically, they are correct. So what I want to also do is that I haven't distinguished the move types for the different pieces. So like for example, in a pawn, right, for the pawn, when you are generating legal moves, here this should be, we should classify this as a pawn jump. And I don't think I've created that class yet, but let's see what happens when I say pawn. Oh, we have pawn jump. So this is just a, yeah, this is a convenience. So we're going to set this to be upon jump when the offset is equal to 16, right? And when it's 7 or 9, we should say that this is upon attack move, right? And we need to mention what piece that we are attacking, I believe. Piece on candidate. Same here. Upon attack move. Piece on candidate. And I think there's definitely still more to do here, but let's see. That's improved. We still haven't taken care of the situation of en passant. But I think that should be fine for right now. Let's see. Alright, so why don't we also look at, why don't we go to the move class? I think I left a bunch of stuff out on move that might help things. We've got the board, the moved piece, the destination, and we also want to introduce final protected final. Let's do that for all of these. Protected final. Boolean is first move, right? And we're going to say this dot is first move is equal to moved piece is first move, right? And we're going to have another we'll have another constructor here that's convenience private move final board, and we'll see where it's used later. Board and final int destination coordinate, and we'll say this dot board is equal to board, this dot destination coordinate is equal to destination coordinate, this dot moved piece is equal to null, and this dot is first move is equal to false. This is really going to be a convenience to refactor up the null move a little bit. So for the hashcode method, we need to update these things, right? So moved piece, destination coordinate, and result is equal to prime times result plus this dot is first move. This dot moved piece the destination coordinate, this dot moved piece dot get piece position. We want the piece position, the destination coordinate, the moved pieces hash code, which is going to include whether it's a first move, which is going to include whether it's the first move or not. So here in equals, we're going to say that the destination coordinates are equal and the moved pieces are equal, and we should also check that the get current coordinate is equal. And we have a bunch of getter methods here. And then we have our execute method for the base class, which is correct. Don't need that anymore. No. And this is just a comment for ourselves. We'll have a method that we call undo that we'll write later. So let's look at major move next. We'll go in order here. Yeah, in terms of what did I do with major move? Pawn jump, attack move, pawn move. Bear with me, guys. Major move. So for major move, what we want to do, we have the constructor, which is correct. We're going to override the public boolean equals final object other. This is just boilerplate code here. Return this is equal to the other, or the other is an instance of a major move, and super dot equals other. And the toString for a major move, let's see if we can get this correct. What we're going to say, public string toString. So now we'll be able to print moves out in a way that is more meaningful. We're going to say return move piece dot get piece type dot toString, and we're gonna have to come back to this, but for now we'll say board utils dot get position at coordinate this dot destination coordinate, and we need to write this method, right? So let's do that. So here we're going to write a method called public static int get coordinate at position final string position, and we'll have another method too called get public static int get position at coordinate. So this is going to return the algebraic notation, right? So like the PGN algebraic notation of the move when you give it the destination tile, get position, or even the current tile. So final int coordinate, and this one will say return algebraic notation of coordinate. This doesn't exist yet. And this one will return position to coordinate dot get position. So we're going to have an array, and we're going to have a map. So we're basically going to have a way of right. So let's declare at the top of this class here two member fields. We'll say public static final string array algebraic notation is equal to initialize algebraic notation. And we'll have another method called public static final map of string integer position to coordinate. Is that what I called it? Yeah, hold on. position coordinate is equal to position to coordinate is equal to initialize. This will be the last thing that we do here. Initialize position to coordinate map. Right? So now all we need to do is, let's see, what is this complaining about? This is complaining get position at coordinate. Position at coordinate. Did I get that wrong? Final static map string to integer. That should be right. Well, let's initialize these. So I'll tell you what, we'll stop here, and in the next video, and I'll try to put up another, I'll try to sort of crank it up to 2 videos a week. We'll stop here, and we will, in the next video, finish this. But basically, like, what we're doing here is that we're going to have, and you can look in my GitHub repository to see how this looks, but we're basically going to have a way of saying, if I give you A8, you're going to return back 0, right? If I give you B8, you're going to return back 1. And if I give you 0, you're going to return back A8. And if I give you 1, you're going to return back B8. That's what these 2 methods are going to do, and they're going to be used in the toString method of our move class. So we're going to, thanks for bearing with me if you've gotten this far in this video. I know it's a little bit boring, but what we're going to do is we'll update the move class. We'll get all that stuff fleshed out. The pawn class, we'll get the en passant working, and then shortly thereafter we'll go back and do the finish off the GUI. Remember, we said that we had those panels on the left and the right that were for captured pieces and the move history, and that's basically going to be the basic engine. From there, we're going to build out an AI and allow you to parse games that you download from the internet and things like that. So hopefully this is going well for you guys. It's definitely exciting for me. Please continue to tune in, subscribe, and like the videos, and we'll see you in the next one.